I'm going to go ahead and introduce the presenters who are apparently lost in the hopping world while Steve is trying to rein them back in. Cheung Chan, AIA, served as the project manager on the 111 East Grand project, working closely with the development team from the early planning stages through construction of the project. He coordinated the efforts of all the consultants involved. With over 19 years of experience, Cheung has worked on various project types. He's worked with multiple firms, including HLKB, Envision Architecture, and BNIM. He's a graduate of Iowa State University with a master's in architectural studies. Eric Neuhaus, AIA, also worked as an architect on 111 East Grand. He was working with the development team from the schematic design through completion of the project. He worked closely with the mass timber engineers and contractors through the construction documentation and construction phases. He's a recent graduate of Iowa State University with the bachelor's in architecture. Eric has worked with OPN Architects and Olson Kundig prior to joining Neumann Monson.
Thank you for the introduction, and thank you for having us today. So as George mentioned, we're going to talk about some mass timber using the 111 East Grand as a case study. We're going to start giving kind of a brief primer, the history of mass timber, where it's been, where it's going. We'll get into the team structure of the project and how that worked with the mass timber consultant and the interaction with the contractor and owners, the different timber typologies we looked at early on in the project and their properties, the design concept and basic schematic of the project, and then the construction process we went through. So to begin kind of way back, the etching on the left here is from Marc Laugier on his essays on architecture, and he was a French Jesuit priest who essentially did not agree with the opulence of Baroque architecture, and this etching is kind of his theoretical basis for that. It's a picture of this idyllic woman, perhaps a personification of architecture, pointing to a young, naive child, kind of pointing out kind of a simple, basic post and beam structure that's made of wood, kind of talking about architecture at its origins, its fundamentals, and its simplicity. And then on the right, we have an image from Gottfried Semper's primitive hut from the exhibition of 1851. He essentially had the same theories on the basic tectonic nature of architecture, seeing a timber post and beam building, and using the Caribbean hut, as kind of an anthropological reference for his point of theory. So as cities grew and urban areas densified, there were fires. We're probably most familiar with the Chicago fire here in the United States. And essentially this kind of changed the perception of wood overnight to a lesser building material in a sense. So it became more known with like houses and residential smaller scale projects. And steel and concrete kind of took over the majority of construction in urban areas. So since then, there's been a resurgence, and I think this is less of a nostalgic look back, but more of a response to the current global situation in regards to climate and different construction methodologies to kind of reduce the greenhouse gas emissions the construction industry outputs. So this is kind of an image from Michael Green Architects. They kind of reimagined the Empire State Building being constructed as mass timber. And I'm sure most of you have seen taller buildings kind of on the agenda for future mass timber projects to go higher and higher. So most of you have also probably seen these statistics regarding the energy that the construction industry uses. Essentially, concrete and steel have to be heated up and go through a very rigorous process in terms of embodied energy, whereas wood, we have the bark that can be removed, the logs can be sawn and cut, and on average, 99% of every tree brought to the mill for processing is used. So there's very little waste relative to other materials. And many lumber companies are using woody biomass, such as the sawmill residues, to power their plants. So with regards to embodied energy, there's like 1 ton of masonry bricks that requires approximately 4 times the amount of energy in comparison to wood. Concrete is approximately 5 times, steel is 24 times, and aluminum is a staggering 126 times. So we can see how wood has a lot of advantages with regards to embodied energy. So this was an exhibit done in 2013. It was called In the Scale of Carbon. It was a 3D exhibition, but this is a 2D graphic essentially showing various architectural materials that can be produced using 1 ton of CO2 emissions. So the larger the cube, the more of that material can be produced per unit of energy. So we can see how the woods and the stones and the clays can be produced in much more abundance relative to steel, recycled steel, aluminum, and other materials. So then we get into kind of the different aspects of mass timber in addition to the embodied energy and the benefits of that. There's kind of a very humanistic level it presents as well. Biophilia is kind of a big thing and continues to grow. Essentially, biophilia is the inherent human inclination to associate with nature, incorporates natural materials, use of natural light, vegetation, nature, and other experiences brought into the building that are experienced in the outside world. You've probably heard of different benefits, including stress reduction, lowering of blood pressure, lowering of heart rate aggression, heightened concentration, and even possibly boosting creativity. So essentially, this mass timber allows the exposed structure to become the finish and helps promote and further those biophilic aspects.
So 111 East Grand, it's a mixed-use project that has retail on the ground floor and speculative offices on the upper 3 floors. It's the 4th project that we have worked with the same developer groups. In this particular graphic, you can see kind of the foreground is the 111 East Grand project, and then kind of in the background to the right a little bit is a parking ramp that we work with the same developer on prior to the 111. And then a little bit to the left in the background, that is a mixed-use residential retail mixed-use building that also was by the same developer. So the way the project team is structured is that it's the procurement method is with a selected general contractor, Ryan Companies, coming on board early on the project. So it wasn't a bid project. So we had the construction arm helping us along even during the design phase. And then the mass timber supplier / design builder, they are under the contract of Ryan Companies, the contractor. And then Neumann Monson holds the structural engineers contract under us, and then JSC, Rittman Property, Christensen Development, and Ryan Companies, their development arm, they're all kind of co-developer / owner of the building. And the MEP design is also held by Ryan Companies, the general contractor, as design built MEP contractors. So the reason we kind of brought up the fact that this is the 4th building that we've worked with the same developer groups is because we think that it took a little bit of sort of trust building through the previous project. It may not would have taken all 4, but the point is we brought, there was some trust previously developed that the developer team felt comfortable with us proposing sort of different construction method that is a little bit newer to this country anyway, for this particular project. And with that, they were willing to kind of continue down the journey, and then we make a trip to Minneapolis to look at the T3 building, which is a mass timber building with nail laminated panels, which is slightly different from what 111 ended up using, but similar. We'll go into that a little bit more in depth later. So we carried the mass timber idea throughout the whole process, but at the same time, we also carried the steel and concrete kind of comparison through the pre-design and schematic design stage so that the owner have a comparison, and it's at the end of the schematic design that they kind of pull the trigger, make a decision on utilizing mass timber for this particular project. We interviewed 4 mass timber suppliers, and those interviews happened a little bit actually prior to the decision making, so that one is to equip the owner with the more accurate cost information, and also have the have the selected mass timber supplier ready to go once that decision has been made.
So these are some of the different timber typologies we looked at early on. The first of which you're probably familiar with, is CLT, cross-laminated timber. This is essentially plywood that's enlarged, where each successive striation is running perpendicular. This creates a two-way span. This is kind of the only typology we looked at that allowed for that to happen. Our building was pretty regular, so we didn't feel like we necessarily needed to have the two-way span capability. The second of which Cheung already mentioned was NLT, and that's what T3 was. These are essentially successive 2-bys that are lined up on end, as you can see here, and then they're nailed together with several metal fasteners. And then DLT, dowel laminated timber, this is where we ended up for 111. It's essentially very similar to NLT, with the exception of no metal fasteners are used. Instead, it's hardwood dowels that are hydraulically inserted into the 2-bys. And it's essentially, it creates a friction fit between the hardwood dowels and the softwood lumber. So there's no glue needed, as in CLT, and there's no needed for metal fasteners, as in NLT. So essentially, it's an all-wood product. These are some diagrams from our mass timber supplier, StructureCraft. This kind of shows their process and how DLT is constructed. We start in the top left, essentially taking a 2-by, cutting it down to size, the finger joining them together to create longer panels and spans, running that through a profile molder. And we'll talk about kind of the curves and stuff we used on our project. And then that lower right or lower left-hand image, you can see that large press. And that's essentially taking all those individual 2-bys, pressing them together. And then that's where the hydraulic or the wood dowel gets hydraulically inserted through the entire panel. And then once the panel's made, that's run through a planer. And then the last step you can see there is the CNC machine. This is a big difference between NLT, is that all the metal fasteners don't really allow for this kind of CNC portion of the panel because of the randomness, whereas DLT, you can kind of strategize where you want those hardwood dowels placed with relation to any openings you may want to have in a specific panel. So these are some images from the plant at StructureCraft. On the left, there's that large press where the DLT panel gets made. For some scale, I believe this is one of our panels that were being fabricated here. So our panels were 6'8" by 40 feet in length. And then on the right-hand side, you can see that image, kind of a cross-section or an end profile of the DLT and all the individual strands. This is a closer version. This is very similar to one of the smaller samples we received. You can see the individual 2-bys and then the hardwood dowel going through them. You can also see those little kerf cuts in each strand. That's essentially for the wood's going to naturally move over time. So that kind of relieves the visual movement that would create once the panel's set in place. And then on the right, there's just kind of an image from below of one of the first panels that was fabricated for our project in their plant. So as I mentioned, there's several different options with DLT. On the right or the left-hand side of the image, you can see a lot of the different profile options. We essentially went with a standard 1/8" kerf cut on each panel. But you can see there's also options to do a larger curve cut and even introduce acoustic insulation if you want more insulative and acoustic properties between your floors. And on the right, we even have options to integrate systems within the DLT panel. This obviously creates issues depending on what construction type you use, and we'll kind of touch on that and how we studied that throughout the process of our project.
Like I've mentioned before, this is the 4th project, and then we kind of highlighted actually the fifth project. Sorry about that. We highlighted kind of the buildings that we work with the same developer group on, and it's all within kind of a 2-block area that is by the Des Moines River. This is on this graphic, the highlighted one is where we are at, and our office actually, after the building is completed, has decided to lease one of the ground floor space, and we're currently located within the building. And then to the south is that parking ramp that I mentioned earlier, and then there's another open lot that is on the south side that is wait to be developed yet. So here are some images of the different projects that we've worked with that developer group with. The first one is 350 East Locust. It's a mixed-use residential building, and at the top of the building, the glass penthouse is the main developer's JSC Properties office. That's where they're located. And then the second and third project kind of they went on simultaneously at the same time. That it's one is the mixed-use residential retail. It's called the 219 East Grand, and then the parking ramp is E2P parking ramp that is right behind the 111 East Grand building.
So this is kind of a basic outline of 111 there on the north. You can see the restaurant and retail spaces on the north, and then essentially the core is on the south, adjacent to the parking ramp. So with regards to the process we went through, we used Revit for the project, and then we worked with our mass timber suppliers along the way. They essentially took our early Revit drawings into CAD, and then they produced their mass timber shop drawings, and we went back and forth and kind of collaborated on that process with regards to specific details, layout of the panels, and things like that. And then at the end, or before construction and during construction, we had Ryan Companies bring all the models into Navisworks, so we could see where any clashes happened or any conflicts were arising throughout each different discipline. So just to touch on some more points of the mass timber, here's a photo as it was under construction. Obviously the aesthetics with regards to wood, leaving it as the exposed structure, you have the opportunity to create this more tactile experience as well as visual. And there's even kind of a olfactive experience with regards to the smell of the timber. As it was being put up, there were times where you could walk to the site. If you were downwind, you could actually smell a bit of the timber and kind of that pine smell, as well as smelling it when you're inhabiting the space. As Cheung mentioned earlier, how we carried mass timber with steel and concrete during the project. There was a slight premium for the mass timber. The owners were willing to do this after we had discussions with them and talked through the pros and cons and expectations of what was to arise using mass timber. And then fire also seems to be a big question with the timber. Essentially, mass timber has kind of the sacrificial layer on the post and beams. So if we take the image in the bottom right, for example, and say that's a column, you essentially have this char layer around the entire exterior, preserving the cold zone and maintaining structural integrity within the center of the column. So the center of the column, or the cold zone you're seeing here, is actually the size the column needs to be, and then it's kind of increased for size to achieve that fire rating. So we looked at some different construction types early on. Obviously type 4 is associated with heavy timber. I'll also add we used the 2015 IBC at the time of this project. So essentially we ended up with type 3B construction. So this allowed us to have 0-hour ratings on all our floors and interior partitions, only requiring the exterior columns and bearing walls to be 2-hour rated. So these are some diagrams we looked at and studied amongst ourselves and with the ownership team. There was a point in time when the project was considering going 5 stories. So that's why we kind of explored this 5-story option. So you can see here the type 3A or the type 4 would have required a 1-hour rating on every floor, which would have required all the connections to be intimescently painted and things like that. And then we also looked at a podium structure, but I think we decided that with the retail being on the ground floor, the public wouldn't get to necessarily experience the qualities of mass timber at that point. So we ended up over on the far left with the type 3B, where the entire structure, minus the back core of the precast, was all mass timber. The ground floor was precast, or excuse me, the ground floor was mass timber. And then the only 1-hour separation we needed was between 1 and 2 for assembly purposes, separating the assembly spaces and the business spaces. So this is a basic cross-section of our DLT panel. On the left is essentially right in the center of the panel. We use 2x8s for the floors and 2x6s for the roof, excuse me. And then along with that, there's a 1/2-inch layer of OSB, which comes already secured to the top of the DLT when the panel arrives. And then we put 3/4 inches of Acoustomat on top of that OSB, and then a 3-inch concrete topping above that. In the detail on the right, we're looking at a place where the 2 panels come together. So we can see this larger gap at the bottom and the smaller gap at the top. The smaller gap is what is kind of standard on the DLT panel, which is 1 inch. And we worked with StructureCraft and asked them if they could leave off an extra strand. Essentially, you're seeing there is a 4-inch gap. And we wanted to utilize this gap to use it as a chase to lay conduit and lighting in the ceiling to essentially keep the ceiling free from obstructions or minimize any disturbances as much as possible. And then this photo just kind of shows during construction. This is looking directly downward at that panel gap. So you're seeing the gravel on level 1 below where that actual gap is. And then the OSB, you can see how it comes to the edge nearly. And then the bottom portion of that shows the OSB they come back with after the panels are set in place, and they essentially splice them together. So this is a basic floor plan of level 1 of 111. So essentially there's a precast core, a series of panels that are 10 feet by 30 feet, and there's 2 layers of those, so 60 feet in height total in the back. And then along the 20-foot grid, we put a series of precast buttresses, and this helped provide lateral stability for the building. And then we filled in the stair, elevator, mechanical cores with the precast. And then that creates the service portion of the building. Going north from there, we have our mass timber components. So these would be the beams extending north as well as the columns. And then this is one of the panel plans that was produced by StructureCraft. So these essentially show each panel. You can see how they're numbered. And each panel arrived on the truck in chronological order and then was removed and placed in its proper location. So it was a very efficient process from that point. This graphic shows an upper floor. This is level 3, for example. So this is what a typical tenant would see when they arrive. So once again, that service core in the back. The highlighted blue in this case is the corridor area. And we worked with StructureCraft to use an upturned beam. So the image on the right shows that smaller beam with regards to the depth. And so this essentially allowed the mechanical systems to be ran in the corridor while maintaining a clear 8-foot height when we put the drop ceiling in there. So this is a basic diagram of the building. Like Cheung had mentioned earlier, there's the parking ramp to the south, 111 to the north, the precast core adjacent to the ramp, the mass timber components coming out of those. And then on the right is just a series of images of the different kind of kit of parts, if you will. On the top is the DLT panels that were on the truck. Once again, you can see those numbers, how they numbered them on the ends. The beams and the columns as well. The beams and columns came from a plant in Europe, and you can see how they're numbered as well. And then you can see those metal plates on the beams, and those metal plates had to be placed in the factory in Europe before they arrived here. And because of that, with our 1-hour separation between levels 1 and 2, the intimescent paint had to be coordinated so the European standards of intimescent paint lined up with the United States standards of intimescent paint. So this is a diagram showing the construction phasing. The project actually wasn't built level 1, level 2, so on and so forth. It was 3 towers moving east to west. So essentially tower 1 went up 4 stories, then tower 2 went up. And then the dimensions here, the dimension strings you're seeing is the reach of the crane arm that would have to be required. So the crane essentially sat in the footprint of the site and then backed up. And this allowed only 1 lane of traffic to be closed on Grand Avenue, which is kind of a main thoroughfare into downtown. So traffic on that street could still be maintained during construction. So these are some erection photos of the precast going up. You can see the parking ramp behind there. The precast took about 2.5 weeks to go up, and that was all temporarily braced before the timber arrived. And these are some erection drawings that StructureCraft provided for the project. This essentially shows their sequence. Once the precast is up, the columns arrive. And you'll notice here how the columns, each column has to be temporarily braced. This is different from a steel building with regards to the entire building doesn't get erected and then it gets racked into place. Rather, each mass timber component has to be plumb as it's placed. And then once all the columns are placed, the beams come out. And then after the beams, the DLT panels are laid atop that. And then it's kind of a repeat process, each floor up. So these are some details of the beam connections to the DLT panels. On the left is more of a typical beam connection. You can see those large fasteners that go down through the panel into the beam. And then on the right is that upturned beam we mentioned that was spanning between the corridor and the precast buttresses. And you can see how that upturned beam kind of lies within the section of the DLT panel. So once again, these are just the photos of the individual components. Essentially, the beam on the left kind of slipped into that pocket of the column on the right, and then you see those 2 holes in the column. That's essentially where the next column up would be inserted with 2 rods using epoxy. And so here's kind of that column-column connection on the left, and then on the right you can see the columns with those metal plates and rods at their base. So then we get into the timber erection sequence. So this was on the east side of the building, phase 1, going up, just like the diagrams indicated. The columns came first, then the beams, then the DLT panels got laid atop those. And the first one took about 2.5 weeks. StructureCraft had sent out 2 foremen from their plant. And then there was 6 to 8 carpenters, local carpenters on site. And that was the entire crew during the entire duration of the mass timber erection. So it was a very minimal crew, not much noise. I mean, everything was, the panels were already prefabricated, so it was a matter of just lifting them into place, anchoring them and fastening them. So this is kind of in the middle of phase 1, that first tower that was going up. You can see the individual braces on the timber columns. This is phase 2. This is kind of the center of the building. Going across. This took a little less time. I think the learning curve had become less steep at this point, and they were used to working with the material and how it interacted. So you can see their phase 2 moving west, that second tower going up. And then I should also mention, you'll see these steel columns on the bottom. These steel columns were exposed, and thus under type 3B had to have a 2-hour fire rating. We initially explored using mass timber columns in this situation, but to achieve a 2-hour rating with a 100% mass timber column would have required a very large cross section. And with regards to the interior columns, I think the proportion would have been off. And there was also some concern by the ownership team of vandalism if someone comes by, and you can only sand away so much of your structure, obviously. So we ended up using a 6x6 steel tube in this case. We spray fireproofed each one of those steel columns, and then we cladded that with wood, which we'll discuss later on. And then this is that last kind of phase 3. Phase 3 was the largest. Each was, phase 1 and phase 2 were 4 bays. Phase 3 was 5 bays. So that's why this one took a little longer. And then that's kind of the basic, the entire structure is what you're looking at here when all 3 phases were completed.
So the exterior of the building is metal frame clad in a metal panel that's made by Millennium Panel. It's called a Zalmac. And all the loads are being carried at the second floor level so that it allows for the other floors movement up and down to be accommodated within the framing system. Here you can see the cold beams that is situated at the second floor level that the stud framing rests on, and sort of the exterior insulation and cladding shown in the detail there. So this is kind of the final kind of cladding when they're installed, kind of final photograph of the building. The panel itself is a zinc-coated steel panel system, single skin metal that because of the coating, it actually sort of changes. It doesn't provide a completely even surface like a painted metal would, and that's kind of what we like about this product, is that it still keeps that more natural appearance, more natural quality to it. And then according to the manufacturer, after heavy rains, that because of the water, how it where water may rest on the panels, the zinc may move towards it, so it will change as kind of some of that appearance of the panel as well.
Cheung, can I interrupt here? We had a question from Andy Coleman. What
Sure.
provided lateral stability on the Grand Street side of the building?
I believe all the lateral movement one is accommodated by that precast back core on the south side, and then the panel themselves also provided lateral stability to us. So we have no cross bracing or anything, no shear connections along the grand side.
And we have a question from Travis Miller, who will be doing our next presentation on some wonderful wood structure in his own building. Did you have to do anything to protect the wood panels during construction to prevent water staining during the long construction process?
So we didn't, except for at the very top level. Once all the towers is erected, we elected to use a waterproofing membrane to cover up the very top level. But water did kind of just through that construction season, we have kind of an unusual time that we actually experienced about 2 weeks worth of continuous light rain that typically does not happen in Des Moines, Iowa. But so we ended up with some water on the panels, and there was some cleaning up in the end that the contractor had to do on the underside where the ceiling is exposed to remove some of the staining of the wood panel. So with that said, Structural Craft, the mass timber supplier, the DLT supplier, they do have a coating, a temporary protection coating that they can provide, that they can apply while the panel is still in the factory. But we've, mostly because of me not thinking that we could ever see a 2-week continuous rain, we elected not to utilize that protection coating. So hopefully that answered the question.
So yeah, I mentioned earlier that the columns here on the exterior are wrapped. We wrap them with a product called Accoya. Accoya is not a species, it's a product name essentially. The species of wood you're seeing here on these lower columns is radiata pine. And then the process of Accoya, it's an acetylation process where each wood wood member gets impregnated with alcohol and essentially changes the molecular structure from a softwood, which is pine, to a hardwood. So it becomes much more durable. It's a sustainable process. I believe Accoya has a 25-year structural warranty in fresh water or at grade, and a 50-year structural warranty above grade. So since we're on the ground floor here, we kind of used those, you can see those small cast in place kind of plinths that the Accoya kind of rises above. So in the winter season, for example, when the sidewalk's being salted, that the wood doesn't have to experience that kind of erosion or possible erosion.
Yeah, I believe in this particular application, it's actually considered above grade. So yeah, we even get the 50-year warranty on them instead of the 25.
So this is a typical photo of I think this is level 3. So this is what a tenant would see before they occupy the space, essentially the shell. You can see the ceiling, how we, tried to keep it free of systems. There's the sprinkler line. We had to have one of those per bay. I also mentioned here, this is the balcony looking west towards downtown. Essentially, this balcony lines up with City Hall, which you're seeing across the street there. Between this building and City Hall, there's also another lot, and that lot has an easement that also aligns with the front of City Hall. So no building will ever be built essentially north of that City Hall property line. So this balcony is always going to maintain its view towards downtown. And then you'll also see these the windows we use for the individual punch openings. They're aluminum-clad wood windows from Pella. So they have a wood finish on the interior and aluminum on the exterior. And then one window per bay is an operable awning window to allow the tenants some access to fresh air. And then this diagram kind of illustrates, like I said, those kit parts of the beams and columns coming together, how the DLT panel interacts with that. And then this one kind of highlights how we kind of celebrated that gap between each individual panel and utilized it for conduit chases and lighting like that. This photo is the main lobby as you walk into 111, so the elevator bank down at the south end. We used charred wood, Shosugi bond, to clad the lobby. And then we also had some local manufacturers here in Iowa create these benches for us. These were fallen trees that were found in Iowa, and then they essentially kiln dry them and sculpt them to a design we came up with. And each one of those weighs approximately 1,500 pounds, so it was kind of a fun process watching them bring those into the building. And then on the left of the image you're seeing there, that's kind of our office space, our entry lobby, if you will. This is a photo of the restaurant on the west corner. We were fortunate enough to also work on this project. So the idea here was kind of to do a minimal intervention and kind of let the mass timber do most of the talking and get as much mileage out of the exposed structure as we could. And then this is a coffee shop, very similar concept. You can see here, same thing with the lighting, placing those in the gaps of the panels, and then just leaving the timber structure as exposed as possible. And then a shot again, kind of looking into our office there, and then Cheung and I are sitting right in that room with those glass doors on the other side of that wall. So that essentially wraps it up. So yeah, if you have any more questions, we'll be happy to answer them.
Thank you both. That was great. We do have a couple more. Dick Tillman asks, is the transfer shrinkage of the panels an issue? And if so, how do you accommodate it?
The main shrinkage, it would be in sort of that north-south direction from Grant back to the precast panel. But because these are all individual sort of 2x members, basically that there's not enough the in between each of the 2x's. Eric mentioned about that curve cut that is to accommodate any sort of individual members movement that create these is mainly visual concern. So with that curve cut, that gap, variation is not being seen too much. And then he also mentioned the panel to panel gap that is the 1 inch that we enlarge the bottom to the 4 inch size. That's also built in to accommodate any sort of expansion and shrinkage in that direction.
We have a question, given that you were comparing this to the other structural system, the concrete system, Do you know how the rising cost of lumber has impacted the current design using this method of construction?
We don't have that information. The building was completed about 2 years ago, so we were lucky enough to we gotten this building in before all this supply chain sort of high demand, short supply happened. So I think Structure Craft, they're out of Vancouver, Canada. They probably would have the latest sort of pricing information on how they probably would have better knowledge on how the rising cost of lumber is affecting them. I would imagine there will be quite an impact because all the individual members they're 2x8s on all the floors and 2x6s on the roof.
Travis asks, was there an STC sound dampening value determined for this floor assembly? I would think it would perform wonderfully from an acoustic standpoint.
It does perform well from a sound absorption standpoint. That the curve cut, both the wood itself and the curve cut, help sort of prevent, or at least to sort of reflects the sound in different directions, so we're not getting too much of an echo. In comparison to the other structure we would have sort of looked at would be a precast floor deck. And then the trip up to Minneapolis really sort of help us understood that better as well, and including the developer teams, we were quite amazed at how quiet the space was when we visited T3. As far as the STC goes, we try to utilize the Maxon Acoustimat as an in-between layers between the DLT and the concrete topping. I believe with the 3/4 inch, it did perform pretty well in between the upper floors. Between our floors and the floor above, we only use a 1/4 inch Maxon Acoustimat, mostly because we needed 3.5 inch of concrete to accomplish the 1 hour fire rating. So we shrink the Acoustimat thickness, and it's not quite STC, but we do kind of occasionally hear some heel walking back and forth from our space.
Got one more in the chat. James Bergevin, what technology and or specification standards do you use to stain and finish?
We actually left everything with no stain, and I think the only coating that they apply was actually just a clear coat, mostly for construction. And our goal was to sort of leave the timber as natural in appearance as possible. So
yeah, so
go ahead.
There will be some exposed aging over time. And we explained that and talked with the ownership group about that, as well as kind of on the exterior here where all the sequoia cladding is, there's going to be some weathering and graying out, which we're already starting to experience with the project being 2 years old. So I think the idea was to kind of let wood be wood and age naturally, if you will.
So I don't know if that truly answered the question, because we didn't really have much of a finish or staining on the wood itself.
Do you know from your research into the product whether that's often done? To
leave them exposed?
No, to stain or to put a finish on. Is it more often that you see it unfinished, or that you see it with some sort of finish on it?
Through our research, I feel like that we see them more natural, more often that it's left natural, and there are different species of wood that the design team can choose from, and then a lot of time I think sort of any color or sort of variation in colors and warmer tone, cooler tone is more accomplished. Seems like they're more accomplished by picking the wood species rather than staining them.
Yeah.
All right, I see we have no more questions in the chat. I'd like to thank you both. This was really wonderful, informative, and a lot of fun for the audience. We had, it looks like, about 47 people attend, so that was a great turnout. I see that you posted your contact information there, and I hope people can contact you if they have questions.
Absolutely. Yep.
Okay. Well, thank you for attending. We will have about a 90-minute break now for lunchtime.